The design of the cooling system was explained in the previous video in week 9. This was, as shown, a system using a single Peltier module along with 2 fans, 2 heat sinks, 2 pieces of metal as well as the heat sink compound. The 2 metals were both copper, with one of 40 by 40 millimeters in measurements aimed to be cooled, whilst the alternate strip of 30 by 100 millimeters was aimed to be heated. Additional items used included a cup of water and a block of styrofoam. A thin slice was cut into the styrofoam block in which the lattice strip of copper was slid into, being heated from the Peltier on the top side whilst being insulated until the point of cooling was in contact with the water on the bottom side. Insulating and cooling the first piece of copper in the cooling system was done in an attempt to cool the copper as it was being heated by the Peltier module to allow the system to keep cooling the second piece of copper to a lower temperature. Unlike the aimed values of sub-zero temperatures, the metal could only be cooled down to a value of 14 degrees Celsius in reality. This was because of many factors. The single Peltier module we used, being one of a standard model given to us, did not have the ability to effectively cool a metal strip below 0 degrees. Along with this, the environment that the system was tested in was in a warm and humid surrounding, leading to the open metal being heated more effectively than cooled within the system. This could have been fixed with a simple top layer of insulation, but since this problem was found on the day of testing, we were unable to supply ourselves with a form of insulation, but it would have made a significant advantage for future testing. Along with the environmental setup, the power going into the system did not help the cooling procedure. When first trialled, the results led to a value of 40 degrees to be reached for the metal that was aimed to be cooled. This was a lot higher than expected, knowing the temperature within the room was about 25 degrees Celsius. It was soon found that both sides were heating up because the voltage was set up too high. Because there was no previous knowledge about the requirements for the Peltier module, trial and error was used and we found that a voltage of 6 had the best results. Although the results portray that the system was not successful, it did help to cool a piece of metal over 10 degrees. Along with this, it also helped us to learn about systems used within cooling devices such as Peltier modules, as well as understanding the importance of insulation, as well as the ability to use fans to transfer and withdraw hot air to improve a system.